I will explain about power density spectrum properties. As I said, the power density spectrum Sxx of omega, Sxx of omega is equal power density spectrum is defined is proved that is Sxx of omega equal Pxx of omega is equal 1 by 2 phi minus infinite to plus infinite d omega. So this is the power density spectrum for the given random process x of t. So we'll discuss about properties, main properties, important properties for the power spectral density. The first property is that is Sxx of omega, power density spectrum is always greater than or equal to 0. There is no negative value. So always it should be greater. And these are the important for the university exams or anything. The relation between power spectral density and autocorrelation. Power spectral density and autocorrelation. Relation between autocorrelation and uh, power spectral density. And one more name is power spectral density. Power density spectrum, or else Sxx of omega, or else one more name is this is also called as Wiener Khinchin relations. So that is also one more name, Wiener Khinchin relations. So this is university, as per university, that is every year the question will get from this relation between autocorrelation and power density spectrum. So minimum 20 times, that is 15 times, that is previous asked question. So that is equal to, as per Fourier transform, the autocorrelation is Rxx of tau is equal. Just assume the random process for easy to remember. So just assume like this here. This is Rxx of tau autocorrelation for the function e power minus j omega tau. Then Rxx of tau is equal, sorry, power spectral density is power spectral density or power density spectrum Sxx of omega is equal minus infinite to plus infinite Rxx of tau multiplied with e power minus j omega tau d tau. From this, according to inverse Fourier transform, we can write it as Rxx of tau here and keep it as Sxx of omega there only, and take it e power j omega t that side, that is e power j omega tau d omega throughout 360. So this is the relation. Proof is also there. I'll explain in one more class. So Sxx of omega is equal. This is an important property for power density spectrum. So what is Sxx of omega and autocorrelation function Rxx of tau? Very important. These are the relations. And I will explain one more important property, and that is power density spectrum property 3. I will explain property 3. Sxx of minus omega is equal power density spectrum Sxx of omega. Coming to the proof here, we know that the autocorrelation function or Wiener-Khinchin relation is just now we are expected Sxx of omega. Third property, I will explain. Here, we know that the Wiener-Khinchin relations, Sx of omega equal minus infinite to plus infinite, uh, or xx of tau multiplied with e power minus j omega tau d tau here. Now, to get the relation, I am assuming let omega equal minus omega. Then substitute in the above equation minus omega is equal minus infinite to plus infinite or xx of minus tau into rxx of tau into e power minus omega minus of minus plus j omega tau d tau. But this is not equal to sxx of omega. We need to get minus j omega tau. To get that, substitute let tau equal minus tau. Then minus infinite to plus infinite rxx of minus tau is e power minus j omega tau d tau. But according to autocorrelation property, rxx of minus tau equal rxx of plus tau. You can write it as rxx of plus tau e power minus j omega tau d tau. So this is equal to the sxx of omega. Sxx of minus omega equal power density spectrum sxx of omega. So these are the important properties. If you have a doubt, you can send to me. Thank you.